Now let us take up a case study. We shall study the ARPANET network, and we shall see how the routing technique has evolved in ARPANET gradually. And as you know, ARPANET, the Advanced Research Project Agency Network, that is the foundation of the present day internet, and many tools and techniques have been developed in ARPANET which are still being used in present day context. Now the first generation algorithm was based on distance vector routing, which I have already discussed. It was developed sometime in 1969. So this first generation algorithm, as I mentioned, it is a distance vector routing. As you already know, it is a distributed adaptive routing. So there is no central controller. All the nodes take part in routing. So it is a distributed adaptive algorithm using delay as the performance criteria. So each node maintains their distance vector. As you can see, maintains two vectors, di, di1, di2, din. So this is one vector. Essentially this is the delay information for sending packet to node 1, 2 to n, and s is the si is the it gives you the succession node vector to node I. So here, as you can see, the succession nodes, list of succession nodes are given here, si1, si2, sin, the to where succession node for node I, to where it has to a packet has to be forwarded for sending to destination 1, 2 and n. So here di is the delay vector, and dij is the current estimate of the minimum delay from node I to node j. That means from node I to node 1, 2, n, in this way, node 1 to 1, 2, n, this information, this vector is stored. Similarly, the Sij is the next node in the current minimum delay route for the from I to j. So that means based on the delay information, the next hop node is calculated, and these two vectors are stored in each and every node. And obviously for doing that, some calculation has to be done. Periodically each node exchanges its delay vector with all of its neighbors. As we have seen in distance vector algorithm, we have already discussed, the exchange of information takes place with the neighbors, not with all the nodes. So that is being done here, and the interval, as you can notice, it is very frequent at the interval of 125 millisecond. And using the incoming delay vectors, a node k updates its vectors as follows. So it finds out the minimum delay path for all I in A using skj is equal to I, using I that minimizes the expression above. So this expression, that minimum value is calculated. Here A is the set of neighboring nodes from k, and iki, that's iki is the current estimate of the delay from k to I. So the minimum value is taken as the delay information, and which is being used to compute the least cost path, maybe by using that Bellman-Ford algorithm. Here the estimated link delay is simply the queue length for that link. So we have already seen, say suppose this is a particular node, and these are the links, outlinks. So the queue length in each of these for each of these links is being used as a representative of the delay. So in building the new routing table, a node will tend to favor outgoing links with shorter queues. So in the link in which the queue length is short, obviously whenever the new routing table is made, a node will tend to favor the outgoing links with shorter queues. Since queue lengths vary rapidly with time, a thrashing situation may result, as I mentioned earlier. So whenever this thrashing situation occurs, because by the time the next routing table is formed and packet is forwarded, that queue length had changed. And so what can happen, again the routing calculation has to be done. So a packet continues to seek out areas of low congestion rather than aiming towards destination. So suppose this is this is part of the subnet, this is part of the subnet. So initially this part of the subnet, the packets are forwarded in this direction because of smaller queue. So there will be congestion here, and whenever it is found that queue length has increased, it is forwarded in this direction, so there will be congestion here. So instead of going towards destination, and this condition is known as thrashing, as I have told. So this is the problem that can arise in ARPANET fast generation network.